Hi, this is going to be lesson 3.4. We're going to be talking about multiplying rational numbers. So let's get started. Okay, so like I said, this will be lesson 3.4, multiplying rational numbers. Today your objectives are I can multiply rational numbers with the same sign, and I can multiply rational numbers with different signs. The standard is NS2. Apply and extend previous understandings of multiplication and division and of fractions to multiply and divide rational numbers. So the good news is that the rules for multiplication of rational numbers are the same rules used for the multiplication of integers. So here's my math meme for the day. Anything can happen in school, but math teachers can never be absent. And I see that every day as you guys are sending me your math questions and your science questions, and that's awesome. That means you're engaged, you're learning, you're trying to do your best. So keep sending me those questions. Never feel afraid to do that. Okay, let's take a look at the rules. I'm going to minimize myself so you have the full screen. So if you remember the rules, positive times a positive is equal to a positive answer. A negative times a negative is equal to a positive answer. Careful on that one. A lot of people get that one messed up. A positive times a negative is equal to a negative, and a negative times a positive is equal to a negative. We can sum that all up by saying same signs, the answer is positive. Different signs, the answer is negative. So here we have two positive numbers multiplied together. They get a positive answer. Two negatives multiplied together. Both of those are the same signs. They give a positive answer. These are both different signs, a positive and a negative. They will give you a negative answer. Now, what's the difference between an integer, which we learned about last unit, and integer or a rational number? Well, integers include numbers like -1, -2, -3, -4, or going the other direction on the number line, 0, 1, 2, 3, 4. They're supposed to be commas. So any counting number that you would have learned in kindergarten and any negative counting number are integers. Rational numbers, on the other hand, are the in-between numbers like -1/2 or -3.62 or +2.5 or +31 and 6/7. So any number you can think of that is in between the counting numbers and the negative counting numbers are called rational numbers. So today we're going to be multiplying fractions and decimals. So let's take a look. Here's our number line. The first thing we should do with our number line is figure out what our graduations are. So I'm going to start with just this one section here to take a look at what we've got. So we have 4 little spots. We have 0, we have a tick mark, we have a tick mark right in the middle, and then we have another tick mark, and then we have the number 1. So what is this middle tick mark? Yes, that should be 1/2. What is the first tick mark here? 1/4. And what is the third tick mark here? 3/4. So it's good to know what we're talking about on our number line. Could also call these decimals. The first one would be 0.25. The middle would be 0.5. The third one would be 0.75. Okay, now that we know that, let's do a problem. -2 times -3.5. So what this is really saying is we have two groups of -3.5, but we also have this negative sign. So let's talk about that for a minute. So this is really a group of -3.5. And we always know that negatives go to the what direction on the number line? They go to the left on the number line, correct? So if I have two groups of -3.5, you'd normally think they would go like that, some distance, right? However, because you have this negative sign here, that means they're going to go in the opposite direction. So we are going to make them go this direction instead. So two groups going the opposite of what they normally would go. They'd normally go to the negative direction. They're going to change and go to the positive direction. So let's see how that works on the number line. So there's our first group of negative 3.5. Again, it's going to the right because of the negative 2 groups. So notice how it went 1 unit, 2 units, 3 units, and then it went 1/4 past that unit. So that lands right on that line. And then here's our next group of negative 3.5. That's going to go from here. So this will be 1 unit, 2 units, 3 units, and then 0.5 more is going to land us right on the 7. So there we are. Did I say that we were here? We should be here. 3.5, not 3.25. Okay, so our answer is positive 7. Why? Because we went to the right, because we had the opposite of negative 3.5. Negative 2 made us go the other direction. So there's our answer, positive 7. Another way of saying that is two negative groups. They cancel out the negative 7. Okay, you ready to try another one? Let's take another one here. Again, there's our rules. Just remember, same sign, positive answer, different sign, negative answer. There's our number line. It looks the same as before with the 4 tick marks there in between. So this time it's negative 3 times negative 1.25. So this negative 3 here is the groups. So there's 3 groups of negative 1.25. Normally you would go to the left with a negative number, but because this is negative 3 groups, you're going to turn around and go the opposite direction with your 1.25s. So there's your first group of negative 1.25. It starts at 0 and it goes to the first mark past the 1. That's negative 1.25. We need 3 groups of those, so let's bring out another group. And that one is going to go 1.25. So it's going to go from this mark to the first mark in the next unit, and then a 1/4 of a mark further. So now we're at 2.5. And we have to do one more group of negative 1.25. And there's our last group. Where did we land? We landed on, what is this number right here? Right, positive 3.75. Notice how we ended up with a positive answer. We have same signs. They're both negative signs, right? Negative times a negative was going to give you a positive as pictured on our number line. So the answer is positive 3.75. So the 3 negative groups will cancel out the negative 3.75, giving us the positive 3.75. Okay, here's our rules again. And this time we're going to do this without the number line. So we have negative 3.5 times negative 2. Same one we just did on the number line. And this time we're going to multiply instead of showing it on the number line. So we do 2 times 5. That's going to give you 10. So we put down the 0 and we carry the 1. Then we're going to multiply 2 times 3. That's 6. And then we're going to add the 1. That's 7. And then is our sign positive or negative? 2 negatives give us a positive, right? And we have to put our decimal in there. Don't forget, because we have one number after the decimal here, so we need to have one number after the decimal there. So 7.0 is the same as 7, which is what we got on our first number line. Okay, this was the second number line, negative 1.25 times negative 3. And notice how I am not putting the 3 over here. I'm just lining it up, pretending like I don't even see the decimal, just lining it up like I would a normal multiplication problem. Then I'm going to multiply the negative 3 times each number above it, starting with the 5. So negative 3 times 5, is going to be 15. So I'm going to put down the 5 and carry the 1. Then I'm going to multiply -3 times 2. It's going to give me 6 plus 1 is 7. Then I have to multiply the 3 times the 1, which is going to give me 3. How many numbers after the decimal do I need? Well, I have 2 numbers here and none here, so 2. So my decimal gets put there, 3.75. And it's positive because we have same signs. They're both negative and they're multiplied together to give a positive answer. Okay. Here's our rules again. -4.0 times -2.5. Right away, what could I say that the answer is going to be, positive or negative? Right, positive, same signs. They're both negative. My answer will be positive. So let's go ahead and multiply. We're going to multiply this 5 times the 0 and then the 5 times the 4. So 5 times 0 is 0 and 5 times 4 is 20. Then my next step is going to be to multiply the 2 times the 0, and I'm going to do that right here is where I'm going to start my answer. So 2 times 0 is 0. And then I do 2 times 4, which is 8. And then I'm going to add my 2 partial products, and I'm going to get 0 plus nothing is 0. 0 plus 0 is 0, and 2 plus 8 is 10. And we already decided that our answer was going to be positive because we had 2 negative signs. Put that positive back there. Don't have to, it just means positive otherwise. Okay, so that is our answer. Oh, we forgot to put our decimal in, Mrs. Claus, you forgot. So there's one number after the decimal here. There's one number after the decimal here. So we need 2 numbers after the decimal total. So we got 10.00. That is the answer, or just 10. Let's try the next one. It'd be great if you could pause the video and try this first and then come back and see if you got the right answer. Okay, I'm first going to multiply the -4 times each number above it, starting with the 5. 4 times 5 is 20. I'm going to put down the 0 and carry the 2. Then I'm going to multiply the 4 times 7. 4 times 7 is 28, plus the 2 that I carried, 29, 30. So that's going to be 30. I'm going to put down the 0 and I'm going to carry the 3. Then I'm going to multiply 4 times 3. That's going to be 12, and I'm going to add this 3 here, 13, 14, 15. This time I'm not going to forget the decimal. I see I have 2 numbers after the decimal here, none after this number. So I need a decimal answer with 2 numbers after the decimal. So I'm going to place my decimal right there. So that's the same as 15 or 15.00. Okay, it is your turn. So if you're doing this while you're watching the video, go ahead and pause the video and do these few questions and come back. Okay, let's move on. Now we're going to be multiplying rational numbers with the number line, as well as what we were doing before, but this is a little different because we're going to have, I think, opposite signs. So same rules. Yes, this time we have 4 positive groups of -1/2. So the groups this time are positive, so the -1/2 is going to go in the normal direction you would think it would go, which is to the, yes, to the left. There's our number line, and we have to go 4 groups of -1/2. So we start with the first group of -1/2. Notice how it goes from 0 to the mark right in between the 0 and the -1. Another -1/2 is going to put us from here to the -1. How many of these we have to do? We have to do 4 groups of these. So we have to do another -1/2. And finally, the last -1/2. Where did we land? Hopefully it'll circle it for us. We landed on -2. So the answer to that problem, 4 positive groups, to the left of negative 1/2 is going to give you negative 2. Notice how we have different signs, positive number times a negative number. That will give us a negative answer. And there's the proof of it on our number line. Looking at another one, same rules. Gina hiked down a canyon and stopped each time, period. She descended 3/4 of a mile to rest. She hiked a total of 5 sections. What is her overall change in elevation? So she hiked down a canyon. She stopped each time she descended 3/4 of a mile to rest. So here she is going down the canyon. And she went 3/4 of a mile. And she did that again down the canyon. She went another 3/4 of a mile, then she took a rest. I think Gina needs too many rests, but whatever. And then we go down some more. There's another 3/4. Descend means to go down. How many of these groups of 3/4 do I need? What does it say in the problem? I have to go 3/4. How many times? 5 times. So I could keep drawing my picture. I need 5 groups of negative 3/4. And there's the last one, 3/4 of a mile each time, and then she rests. So it's 1, 2, 3, 4, 5. Yes. So let us see. I'm going to clear that now because it covers up our thing. So 5 groups of negative 3/4. Why is it negative 3/4? Because she's descending. She's going down the canyon. There's our number line. So we're going to try to show 5 groups of negative 3/4. So you tell me, am I going to be going to the left with my arrows or to the right with my arrows? Right, I have a negative 3/4. So I'm going to be going to the left. And I have 5 groups of those. Because it's not a negative 5, I'm going to go the normal direction of left for the negative numbers. So I'm going to go negative 3/4. Notice how that's 1, 2, 3 tick marks past the 0. Then I'm going to go another negative 3/4. That's another 3 tick marks past the where we left off. So 1, 2, 3. Actually, I'll draw that for you. So we go 1, 2, 3. And then we have another negative 3/4 to go. So where does that end up? 1 tick mark, 2 tick marks, 3 tick marks. Here's our arrow. There's our negative 3/4. We have 2 more groups to go. Again, 3 tick marks. 1, 2, 3. Here's our arrow. Negative 3/4. And we have 1 more of those to go. So 3 more tick marks. 1, 2, 3. We're going to land right there. Okay, what are we on? What is this tick mark right here? Let me just change colors here. What is this tick mark right here where we landed? What is that? What tick mark is that? Well, we have to go past the number. So we go past the negative 3. And we're not quite to negative 4 yet. So it's going to be negative 3 point something. Negative 3 and 3/4, right? Or negative 3 and 0.75. So let's see how we decide to do this. Negative 3.75. So we could say through negative 3 and 3/4 if we want, or we can say negative 3.75. They both mean the same thing. So 5 positive groups to the left gives us a negative 3.75. Different signs, answer is negative. Okay. Same rules. This time we have 4 over 1 times negative 1/2. Originally it was 4. I put another line here and put it over 1 because I can always put a whole number over the number 1 and not really change the number, because 4 divided by 1 is 4. So I haven't changed the number 4. I've left it a 4. I just made it as a fraction. So now what are we going to do? We're going to cancel our 4 by dividing it into a 2 into it. So divide 4 divided by 2 and 2 divided by 2. So 2 divided by 2 is 1, and 4 divided by the same 2 is 2. So whenever you can cancel, do so. Could I have figured it out without canceling? Of course. I could easily have just done 4 times -1 on top and 1 times 2 on the bottom and then reduced my fraction. But here I reduced it ahead of time. I knew that 2 goes into 4, so that is why I reduced it. And then I multiply across the top. 2 times -1 and 1 times 1. That will give me -2 over 1. And what is any number over 1? Well, it's the number itself, right? So the true answer is -2. Okie dokie. Here's another one. 5 over here times -3/4. 5 times -3/4. Well, I'm going to put my 5 over a 1. There it is. It's over a 1 now. And now if I can cancel anything, I will. But can I cancel anything? Can't cancel the 1 and the 3, and I can't cancel the 4 and the 5. Nothing goes into both of those numbers. So I just have to multiply across the top. 5 times 3, or I should say 5 times -3. That'll give me -15. A negative times a positive gives me a negative answer. And on the bottom, I have 4. So -15/4. So now I got to change this over to a decimal. So I'm going to put the 15 or the -15 on the inside and the 4 on the outside over here now. So now how many 4s go into -15? -3. -4, 3 times 4 is -12 or 12. Now 15 minus 12 is 3. And that 3 I'm going to bring up to the top. Oh, we're going to keep going. We're going to bring down a 0 here. Put my decimal up there. Bring down my 0. Now I say how many 4s go into 30? 7, right? 4 times 7 is 28. I subtract 30 minus 28. That's going to give me 2. I still have a remainder, so I'm going to add another 0 up here and bring it down. And how many 4s go into 20? Yeah, 5. That's going to be getting written right here. There it is. And then 4 times 5 is 20. And 20 minus 20 is 0. So the true answer to this problem is -3.75. Why is it negative? Because I multiplied two different signs. So -3.75. There we go, our answer, -3.75. See what's next. Probably another one. Our rules, same signs, positive answer, different signs, negative answer. 9 times -1/3. What am I going to do first? Right, I'm going to put the 9 over a 1. Now I have two fractions. Notice how I can cancel the 9 and the 3. I can divide 3 by itself and 9 by 3. So I'm going to do that, and I'm going to cancel out the 9 and the 3. The 3 divided by a 3 is a 1, and the 9 divided by a 3 is a 3. Now I'm just going to multiply across the top. A 3 times a -1 and a 1 times a 1. So 3 times -1 is -3. 1 times 1 is 1. -3 over 1 is really the same as -3. Okie dokie, let's do one more here. 12 times -1/5. Pause the video, try this. Come back, see if you got it right. Okay, I'm going to put the 12 over a 1. And I notice that there is nothing that will cancel. A 12 does not divide by a 5, so that won't cancel out. So I'm just going to multiply across the top and get 12 times -1, which is equal to -12. And on the bottom, I'm going to get 1 times 5, which is equal to 5. I'm not going to leave it that way. I'm going to divide. There's my division sign there, right in the middle here. I'm going to put my -12 on the, the inside, and my 5 on the outside. And now I'm going to divide. How many 5s go into -12 without going over? Or just, it's going to end up being a negative answer. We won't think of it as -12 till the end. So 2. So we'll put a negative sign in front of that because we know the answer will be negative. Different signs, negative answer. So 2 times 5 is 10. 12 minus 10 is 2. I'm not finished. I put a decimal place and a 0. Right away, I put my decimal up on the top answer. Then I bring down my 0. How many 5s go into 20? Well, 4. So 4 times 5 is 20. 20 minus 20 is 0. So that answer is -2 4/10. Okay. There it is, -2.4. Okay, you got to try a couple of these kind of problems. Pause the video, do your problems, come back. Okay, now we're going to talk about multiplying more than 2 rational numbers. More than 2. Well, so that means we have -2/3 times -1/2 times -3/2. How do I do that? Well, I do 2 at a time. So I'm going to do, let me just circle it here, get a different color. I'm going to do these 2 first. I'm going to get an answer, and then I'm going to do the last one with the answer I get. So let's see what happens. So multiply 2 at a time. So let's do these 2. Notice how these 2's, I'll keep the circle there. Notice how these 2's will cancel each other out. So that's what I'm doing here. I'm crossing them off. They'll cancel each other out and actually technically become a 1. So what do I get for an answer then? I have really 1 times 1, or just 1 on top, and 3 times 1, which is just 3. So I basically get a positive 1/3. Why is it positive? Because I multiplied 2 same signed numbers. 2 negatives give me a positive 1/3. Now I'm going to multiply my 1/3 here times my -3/5. So 2 negatives gave me a positive answer, and now I'm going to get a positive times a negative, and I'm going to get a negative answer, correct? So I just moved my 3/5 or my -3/5 down. Notice how I will be able to cancel out this 3 here and that 3 there. So let's see that in action. The 3's cross off, they would become 1s or basically not be there anymore. We're left with 1 times 1, or 1 on top, and 1 times 5 on the bottom, or 1/5. And because we have a positive and a negative, our answer will be -1/5. So that is our answer, -1/5. A negative and a positive give a negative answer. We just talked about that, and there is our answer. Okay. Try another one. 3/8 times -4/5 times -5/7. Let's do this 2 at a time. Is there anything I can cancel? Well, yes, the 4 and the 8. 8 divided by 4 is going to give me 2, and 4 divided by 4 is going to give me 1. So let's see how that works. Oh, did I do it? There we go. Cross off my 8 and my 4. 8 divided by 4 is 2. 4 divided by itself is 1. Multiply across the top. 3 times 1 is 3. And 2 times 5 is 10. Their answer is negative because I have a positive and a negative. Remember, I'm multiplying 2 at a time, so now I have to multiply this fraction over here. So I'm going to multiply my answer negative 3/10, this time times negative 5/7. Can I cancel anything? If you notice, yes, I can. 5 will go into 10 twice. 5 will go into itself once. I can't cancel the 3 and the 7. They don't work together. So my final answer then, I have a 2 down there and a 1 there. Final answer will be 3 times 1 on top, 2 times 7 on the bottom. 3 times 1 is 3, 2 times 7 is 14. They're both negative numbers. They will become a positive answer. So the answer to that problem is positive 3/14. So whenever you have 3 problems, take them 2 at a time. Here's some rules for finding the sign of n negative number, or some number, some amount. N stands for the amount of negative numbers. So here, let's take a look. If n has even number of numbers, so that would mean like 2 times 3, those are both even numbers. So n would equal 2 numbers. N gets 2 numbers here. And they're both even, so the product will have a positive answer. If n is negative, the sign of the product is negative. So if we have 2 negatives, negative 2 times negative 3 times 1 more, so this time n is equal to 3 times negative 2 again. So we have n equaling 3, this time 3 numbers. The answer is going to be negative times negative is positive. Positive times negative will be a negative answer. And I think the computer will show us that here, that I set it up here to do that. Let's see. Yep, so I'm laying it out for you. Negative times negative equals a positive. A negative times a negative times a negative equals a negative. A negative times a negative times a negative times a negative is a positive, etc. These are 2 numbers equal to n. These are 3 numbers. These are 4 numbers. These are 5 numbers. And these are 6 numbers. All of the even numbered numbers, any numbers that, so you have 2 here multiplied together, you have 4 multiplied together, and you have 6 multiplied together. That's going to give you a positive answer. Whereas the uneven, there's 3 here, that's uneven, 5 here, that's uneven. That will give you a negative answer. Okay, now it is your turn to give that a try. Okay, what do we got here now? Focusing on higher order thinking. Okay, the ground temperature at Brigham Airport is 12 degrees Celsius. The temperature decreases by 6.8 degrees Celsius for every increase of 1 kilometer above the ground. So every time you go up 1 kilometer above the ground, the temperature will decrease by 6.8 degrees. What is the overall change in temperature outside of a plane flying at an altitude of 5 kilometers above Brigham Airport? So we can use a number line that looks something like this, right? So the airplane, maybe I can draw my little airplane. Don't expect it to look good. It probably won't. It looks more like a, don't know what, but there's my airplane. So if it goes up 1 kilometer, it's going to decrease in temperature of 6.8 degrees. If I go up another kilometer, it's going to go down in temperature another 6.8 degrees. By the way, this is an inverse relationship. As the airplane increases, the temperature decreases. So I'd have to do this. How many times would I have to do this? 5, right? Because I went up 5 kilometers. So this is 1 kilometer up, 2 kilometers up, 3 kilometers up. And then if I go up 2 more, I go another negative 6.8 and another negative 6.8. So I could write an equation for that, which would be negative 6.8 times 5. 5 groups of negative 6.8. Multiply the 5 times 8, that'll give you 40, carry the 4. 5 times 6 is 30, plus 4 more is 34. I have one number after the decimal. I have to put my decimal in there. So the answer is going to be negative because I have a negative sign and a positive number, so negative 34. So that the temperature decreases 34 degrees after the plane has gone up 5 kilometers. What is the new temperature going to be? Well, started out at 12. The temperature went down 34 degrees. This is a subtraction problem, isn't it? Or I like to change subtraction into addition as really 12 plus negative 34. It makes it easier for me to see that what I'm really doing is having two opposite signs and I'm subtracting them, and the number will take the sign, the answer will take the sign of the bigger number, which happens to be 34. So our answer will be negative. So 34 minus 12 is the same as negative 22 degrees. So that would be our new temperature. Find two integers whose sum is negative 7 and whose product is 12. Sum comes with adding, product comes with multiplying. Well, what can I do? So I need two numbers that sum together to give me negative 7. Well, there's a lot of choices, right? However, the product has to be positive. So for the product to be positive, I either have to pick two positive integers or two negative integers. Well, because my sum is a negative number, I can only pick the two negative integers that sum together to give you negative 7. So note that if the product is positive, which it is, it's 12, the only way to get a positive answer when multiplying is to have two negatives or two positives. Since the sum is a negative answer, that means my choices have to be two negatives to get a positive product of 12. What numbers sum to an answer of negative 7 that are both negative? Well, we could do negative 1 plus negative 6. That'll give us negative 7. Or we could do negative 3 plus negative 4. That will also give us negative 7. However, the product of the two numbers has to multiply together to give you positive 12. So 3 times 4 gives you positive 12. 1 times 6, that only gives you 6. So I think we found our answer. Our answer would have to be the second choice. Just negative 3 plus negative 4 equals negative 7. There you are. Now you get to try one of these. Okay, if you've done that, we are back. And I am back. And you are going to get your homework on Google Classroom, lesson 3.4. I'm going to stop my share and say, have a good day. See you next time. Bye.